This particular example is not present in your study guide, so it's not a matter of copying it down. You merely have to watch the demonstration. We've been given the rational function h of x, which is equal to 2x to the fourth plus 3x cubed, which is then all divided by x squared. This particular rational function can be simplified because x squared divides evenly into all the terms in the numerator. So h of x can be expressed as 2x squared plus 3x. Then, using the power rule, we can obtain that h prime of x is equal to 4x plus 3. I'm just going to write that derivative up in the right-hand corner for future reference. Now I'm going to erase the work that I've done, just leaving the original function h of x on the screen. H of x can be described as the quotient of two polynomial functions. The function 2x to the fourth plus 3x cubed I'm going to refer to as f of x, and the function x squared in the denominator is going to be referred to as g of x. We are now going to use the quotient rule that you've previously been provided with, and we're going to show that the derivative using the quotient rule does indeed produce the same answer that we obtained merely using the power rule. H prime of x is equal to g of x times f prime of x minus f of x g prime of x, all divided by g of x squared. We start by filling in g of x, which is x squared. Then we work out f prime of x, which is 8x cubed plus 9x squared. From that we subtract f of x, which is 2x to the fourth plus 3x cubed, and then we multiply that by g prime of x, which is 2x. And then all of that is divided by g of x squared. So we have x squared being squared. In the numerator, all we are going to do now is expand using the distributive property and combine like terms. So when I expand, I end up within the numerator 8x to the fifth plus 9x to the 4, subtract 4x to the 5 minus 6x to the 4, and that's all divided by x to the 4. We combine our like terms in the numerator and get 4x to the 5 plus 3x to the 4, and that's all being divided by x to the 4. X to the 4 divides evenly into both of the terms in the numerator, and we end up with h prime of x is equal to 4x plus 3. Lo and behold, we get the same derivative that we obtained when we used the power rule.